Alright, in this video we are going to talk about what it means to simplify rational expressions, specifically with addition and subtraction in this video. And if you remember, a rational number is any number that can be represented as a fraction. So what we're doing is we're going to look at fractional uh, expressions here. So it's going to look something like this here, where we have two fractions subtracting one from another. And if you'll notice, it's a little bit trickier now because we have variables instead of just numbers. But it's still going to be the same idea and the same process, and I'll show you what I mean here in a sec. But the first thing I want to do is I want to take care of this negative first. I'm going to turn it into an addition problem by multiplying that negative throughout the numerator, and it kind of acts like an invisible -1 that I multiplied everything in the numerator. So the first term is going to stay the same, and the second term is now going to be plus because I've distributed the negative, but now the numerator is going to be minus 3x plus 1, and that is still over x. Okay, so now I've turned it into an addition problem, so now everything is going to be the same. So if you have a subtraction problem, distribute that negative throughout the entire numerator. Basically just change the sign of everything in the numerator, then it becomes an addition problem. Now I'm going to do this part real quick, but if you'll remember, I've got 1/2 plus 1/3. And in order to add these together, I have to have these bottom two numbers, or the denominators, to be the same thing. So we're going to find a common denominator. So I'm going to multiply by 1. So in this case, I'm going to multiply by 3/3, mainly because this 3 over here in the opposite denominator, and then the opposite denominator for the 1/3 would be 2, so I'm going to multiply by 1 as well, right? And what I mean by multiply by 1 is because 3/3 is 1 and 2/2 is 1. So I'm not changing the value of each of these terms, I'm just changing the way it looks. So for example, we can now multiply these out. So 3 times 1 is 3, 3 times 2 is 6. So there's my new fraction there, and then I get the same thing, 2/6 on this one. So if we think about it, 3/6 reduced is 1/2, 2/6 reduced is 1/3. So again, I've changed what it looks like, but I have not changed the value. And from here, I take the numerators, add them together to get 3 plus 2 is 5, and then the denominator stays the same, it'll be 6. So now I've successfully added those two fractions together, but the first thing I had to do is get common denominators, all right? So now let's apply that same idea to this rational expression and simplify it. So the opposite denominator is x for the first term, so I'm going to multiply again by what I call a 1, and then I'm going to multiply the opposite, the second term, by the opposite denominator, which would be 4 plus x over 4 plus x. And again, if you remember, x over x is 1, 4 plus x over 4 plus x is also 1, so I'm not changing the value, I'm just changing the way it looks. So now I have to go through and apply all of my operations. For example, I'm going to take this x and distribute it out. Take this bottom x and distribute that one out as well. So what I have is x squared minus 5x over 4x plus x squared. All right, I'm going to do a similar idea to this one, distribute that out here. But on the top, I have to FOIL it out. If you remember FOIL, or some call it double distribute, but whatever you call it, I have to make sure I multiply every term by every term. So I'm going to get a trinomial on the top of my second number here. So what I get is minus 12x minus 3x squared plus 4 plus x over, and then I have 4x plus x squared when I distribute that bottom. Now what we can see is our denominators are now the exact same. So what I can do essentially is just take every number on the top, or the numerator, and add them together, aka collecting like terms. So I'm going to do that over here. So I've got an x squared and an x squared here. Put those together, you get minus 2x squared. Then I have a minus 5x, a minus 12x, which gives me negative 17, and a plus x, which gives me minus 16x. And then finally, the last term we've got is just my constant of plus 4. So I have plus 4 here. All of that is over my denominator. I'm going to rewrite it a bit. X squared plus 4x. All I did was I wrote it in standard form. And from here, we're going to double check and make sure that I can't factor anything else out, just to simplify it as best we can. And if we'll notice in the numerator, what I have is 2, 16, and 4, my coefficients, and I can factor 2 out of those. So I get minus 2, and then that gives me x squared plus 8x minus 2. And then on the denominator, I have x squared and an x, so I can factor an x out of both of those and get an x plus 4. All right, so now I have successfully simplified or added those two rational expressions. So this original expression and our final simplified version, or added together, is what we get there. So those two are the same value, but we've just subtracted them together. All right, so here's another example. I want you to pause the video, try this on your own, and then I'll come back and we will show you how to do it real quick. All right, so pause that video. All right, so let's go ahead and work this one out. If you'll notice, again, we have two denominators that are not the same. So what I need to do is get common denominators. I've already got it plus, so I don't need to change anything there. I just go ahead and operate like normal. Remember, if we had a negative, we're going to go ahead and distribute it across the numerator. So I'm going to multiply by the opposite denominator, which is x plus 3. I'm going to put that as x plus 3 over x plus 3 times 1 over x plus 4, and I'm going to do the same thing to the other side, but I'm going to use the first denominator there. So again, that's a 1, not changing the value, just changing the way it looks. So now what we got here is x plus 3 on the top, and I have x plus 3 times x plus 4 on the bottom, plus, and if I take this, by the way, if I distribute the 1, it just ends up being x plus 3. Here I distribute the 2, which gives me 2x plus 8 over x plus 3, x plus 4. And now I have a common denominator on the bottom for both of those. That means I can just take all of my terms in the numerator and collect those like terms. So I have an x and a 2x, which gives me 3x, and then I have a 3 and an 8, which gives me plus 11. Then I have in the denominator the same x plus 3, x plus 4. And again, this is the fully simplified version of the original right there. All right, hope this helps. See you in the next one.